You are watching the January 26, 2018 Distinguished Lecture, Operation Morning Light 40th Anniversary Panel Discussion, presented by the National Atomic Testing Museum.
I'm never sure with this set of wheels how long I can actually stand, so sometimes it's easier for me to sit down. I'll start out standing, but that may not last very long. First of all, on behalf of myself and all the others who will join me in a little bit up here on the stage to reminisce about the kind of things that we went through, let me make a point. I was one of the younger ones up there, and I'm 77. And so we all have perfect recall, just not all on the same day. So if we have differences about what we think we remember went on, don't be surprised. And I'm sure we'll be as surprised as anybody in the room. We're really lucky to have with us a wide variety of people that were key players up there in many different ways. And there were some things about this operation that even today are still very unique. Probably the biggest one, when we think about how invasive news media can be and all of the activities that go on in the world today, that was one where they just couldn't get there. We were operating close to the Arctic Circle. We were 500 miles or more from the nearest airport. And the only way that you could get in and out of there was at the courtesy of the Canadian Air Force that we were working in support of. And so every afternoon we would have a get-together, and then we'd have a briefing for the news media there in Edmonton, which was our base of operations. And we would have all kinds of news media there. At that time, all of their cameras were the big film type things. Nobody had any of the modern day electronics that they all carry, and certainly no cell phones. And in fact, it'll be amazing to you what we didn't have from a technology standpoint at that time. So let's give you a little bit of background on this thing. In December of 1977, I had a phone call from this guy here in the front row who made some comment about me getting my rear end over to his office pretty quick, and he had something important to pass on. And so we sat down, and I heard the story about this Russian or Soviet Union satellite that was in big trouble. It turns out that they had totally lost control of it, and they didn't have any way to communicate with it, so they couldn't control any of the little rockets that would aim it or change its course or position. And so this thing was just tumbling out of control. And when you have an object like that, in fact, we're going to get another experience with one of those shortly. It sounds like the Chinese have a satellite that's tumbling around up there and is probably going to re-enter sometime in March. But as it turns out, when a satellite is tumbling like that, your ability to know when it might re-enter gets better each day. You get a little better feel for it, but you still don't get a good idea of when it might actually re-enter. And you start from the standpoint that there's a 70% chance it's going to be in water somewhere in the ocean, since the Earth is covered, 70% of it is water. And so you kind of cross your fingers and say, well, maybe this problem will just go away. The problem in this case, however, and we'll come back to our logo here. You might notice that logo before you leave it, because the State Department didn't have much of a sense of humor. And in particular, my little pointer thing here is not working, but this one works fine. They didn't really take a shine to that thing. But our boss, Ink Gates, and our commander out there, Colonel Garland, thought it looked just great. And Ink Gates and Garland had agreed that it'd be good to do something to have our two teams come together and work together, and so we made T-shirts for everybody, all of the crew. And you'll see that in the pictures that Rex Wyndham over here, one of our photographers, got a lot of pictures of those T-shirts in action. My role up there in support of DOE was to be the commander for support, or commander for all the toys and tools that we bring to these things. And we had just formed this team that we call the NEST team back in the early 70s. So we had 6 or 7 years under our belt, and here comes this thing. And so this was the first time we really went out on a very large scale operation. So that was a first. This is just to prove I was actually there wearing one of those T-shirts. And another fellow that's with us tonight is the second guy, Norm Bailey, from Lawrence Livermore Lab. And he was one of our scientists up there. And I talked to Carl Henry the other day, but unfortunately he wasn't able to join us. The three of us are standing there having a discussion because it turned out I had drawn the short straw to go on one of these 10-hour missions with our boss, Inc. Gates, and the Minister of Defense for Canada at that time, Barney Danson, I think was his name. And so I was talking to these guys who'd actually been out in the field quite a bit at that point to get a rundown on what points we might want to emphasize with this Minister of Defense. Well, the whole thing started with this satellite. Now, this is the entire satellite that we're looking at here. And the front part of it here is all of the spy equipment and the transmitters and communications gear and so on. On the very back end of it, however, is where the reactor is located, and that was providing electrical power for this. Now, this was a 40 kilowatt thermal reactor that actually was producing 10 kilowatts of electricity that would power this thing. And as you'll see later, we found only one part that was not radioactive, and it turned out that was the hog that was using all the power. It was the outer casing for a Klystron, which was a large radar unit that was, this satellite was designed to do ocean surveillance, looking for ships and shallow submarines with this big radar unit, and it had to be at low altitude to get a sufficient return signal. And so these things could only operate for a little over a year before they would fire explosive bolts and separate the reactor from the rest of it, let the rest of it re-enter and burn up. And they would boost the reactor into a 500-year orbit. Now, our calculations of the health physics people said that the reason for concern was that the reactor was fueled by uranium carbide, highly enriched uranium, that provided the core for the reactor. This thing had been in operation for a year, or over a year, and the calculation showed that if one of these 11 hockey pucks that contained, that was a carbon matrix with the little BB particles in it, one of those hockey pucks would be deadly at 1,000 feet. And so there was a lot of concern as to where this thing might re-enter. Would people be at risk? So the people that were at risk, it turns out, in the Northwest Territory of Canada, you'd think that big open space up there with the kind of winter conditions that we're looking at would be pretty sparsely populated, but it turned out that there were over 10,000 people living in that area, and that included Chippewa Indians, Inuits, the Eskimos, and the miners that lived and worked in Yellowknife, that was on the north end of the Great Slave Lake. The Great Slave Lake you may be familiar with if you've ever watched the TV program about ice road truckers. That's the lake. During the winter, that thing freezes over 4 feet thick, and it's a sufficient thickness that you can drive an 18-wheeler across it, and so that's how they resupply Yellowknife every year when it freezes like that. So here, the end of January, this thing re-enters, and no idea what was going to happen to that reactor when it re-entered, because it was never intended for it to re-enter. As it turned out, it didn't fare so well. It wasn't put in any kind of a housing, and as you'll see later, as we started to find pieces to confirm, first of all, was this the Ramashka design that we thought it was, or was it Topaz or one of the other reactors that Russia's been known to work on? Now, again, we didn't know when it might come in or where it might come in, so the National Security Council put Inc. Gates in charge and had our team assemble, and we had 2 C-141s here in Las Vegas loaded with our equipment and personnel ready to go, and we had another one in Andrews Air Force Base in Washington. And we had people from the laboratories come join us on those airplanes, whichever one was closer to them, and then some actually would later on fly up commercial. On the last 3 paths before it re-entered, you'll see that these 2 in particular come right across the middle of the United States. And that's why there was concern. It could have been any other part of the world, could have been any other big cities at risk. But if this thing with that radiation package on it had come down, it would have been a serious risk wherever it landed, except in the ocean. In the ocean, the ocean's a great shield, and deep ocean especially is a great shield, and that'd be a good place to get rid of it. So very early in the morning, this thing decided that it was going to re-enter off the coast of Canada, and at about 200,000 feet over the Great Slave Lake, it came apart. The reactor did, and it started showering down parts. Now, our job was not going to be to try to go out there and recover all the pieces of this thing. Our job was to, first of all, protect health and safety of anybody living under it, and second was to find enough of these pieces to try to confirm that it was the reactor we thought it was, and to guide us in terms of what other pieces might be out there that might be very hot. So that was our challenge. We had good satellite tracks on it as it re-entered, so we knew where it re-entered. And we had the weather data that told us that lighter particles that might come down, that there were basically no winds that night. So we came up with this estimated footprint. The first call that happened was a call from Jimmy Carter called Trudeau and offered our assistance, and that assistance was immediately accepted. And so we proceeded to put our people on board all of the 3 airplanes and get ready to take off. And the place we were told to rendezvous was in Edmonton at the Namao Air Base of the Canadian Forces. And our commander was going to be a fellow by the name of David Garland, Colonel David Garland. And he turned out to be outstanding. Now, when we landed, the first thing that we were struck with was that it's minus 30 degrees here in Edmonton. And so I start hearing this voice in the background that starts quoting somebody named Robert W. Service. And he's talking about the Northern Lights have seen strange sights, but the strangest they ever did see was that night on the marge of Lake LaBarge when I cremated Sam McGee. Yeah. And the person that was telling us those words was Troy Wade. And throughout the operation, we heard that poem more than once. Now, Troy knew the whole thing. He could go through that whole poem end to end, as well as some of the others of Robert W. Service, who wrote poems like that about the travails of the early gold miners in Alaska, trying to survive these kinds of temperatures. Anyway, when we landed and started to get off the airplane, we were wondering about, well, where's our quarters? And the good colonel said, we need you to start looking for this thing immediately. And by immediate, he meant right now. And so the shortest way for us to do that, since these little airplanes that we had wouldn't operate in that kind of weather, is we just took them off of our C-141 aircraft and rolled them up into their Hercules C-130 aircraft and bolted them down, and our plugs were designed so that they would fit. We just plugged right into the power on the airplane, and within a few hours we were able to send both of those missions out to start looking for the radiation. At the same time, the Canadian forces went out to brief the local populations in areas under that footprint that we showed you there a while ago. And one of the places was an Indian village on the south of the Great Slave Lake. And we did kind of get involved a little bit. We went out and watched the Canadians getting ready to go, and they had these really light aircraft that had skis on them, and their team of about 7 or 8 guys were getting ready to get on this thing, and they all had on these yellow suits with a full face mask and gloves and booties and all this kind of stuff. And we said, please don't do that. You're going to scare the bejesus out of these people if you show up dressed like that. And so they took that gear off and put on the regular cold weather gear and still carried their instruments. But they didn't march into these villages dressed like that. And so they proceeded to tell the people what the risk was and warn them about it. And then it turned out that one of the first things that was found was this piece here, which turned out to not be radioactive. And that piece of gear there turns out to be the klystron that was providing the radar for the spy part of the satellite. And that's actually the only piece of technology that we discovered, and it was just a bare, empty, carbonized shell from the reentry. It turned out that they were able to do some radio chemistry analysis and some metallurgy, I guess, on the back side of that thing, and discovered that it was plated with gold and silver and some of the other metals that you would expect to find in a klystron. So that's how we arrived at the conclusion. None of that was arrived at instantaneously, however. It took a while to research that. Then at the other end of the search area, it turned out there were a group of young men that were crazy enough to be out there trying to reproduce a trek of an early explorer that went through the North Woods up there to looking to reach the North Pole. And these guys were camped in Warden's Grove, which was very close to this piece of the Thelon River where this furthest part, this happens to be the containment vessel for the reactor. At that time, we didn't know that, and they were there. They saw all this flashing and a big light show at night. And so the two of them trudged out there the next day and discovered what they referred to as antlers sticking out of the ice. Upon closer examination, they could see it was pipes and not antlers. And fortunately, they did have a Canadian mounted police radio with them, and they started describing what they had, and we warned them to back out of there, and they picked them up with one of their twin otters, again with skis on it, brought them back down to Edmonton, and we were able to talk with them and get their input on this thing. And health physics people went out there too and made initial measurements. So now we have kind of both ends of the search area pinpointed, but we're a long way from finding any of the fragments. These were our two explorers. By the way, the only challenge I got out of you notice they're wearing the same boots we were wearing. That's because their moose hide boots they were wearing, handmade moose hide boots, had been taken away from them. They were contaminated. And the only thing at the end of the operation that the auditors ever challenged me on was, why the hell are you out there buying moose hides? And fortunately, I had a letter signed by Gates that said, buy these guys some moose hides so they make themselves some new boots to go back. and finished their trek. So this footprint now starts to show you a little more detail about what we would learn. We would learn that the little hockey pucks that had the BB-sized fuel in it came apart first at high altitude, and it was like firing a shotgun down on the top of the Great Slave Lake, and you had a density of about one of these BBs every 50 feet. Now, individually at that day, right after it had shut down due to the reentry, they were still pretty hot, but they were very short half-life kinds of radiation present, and so they would decay very rapidly. But the rest of it was a trick, and later we'll get into more about this. But the big problem was, how do you navigate? There's no GPS satellites. None of that's even been developed yet. And so the only navigation tool that we had up there was something called LORAN-C. And LORAN-C is a system that had been around for quite a long time. It was good for, 1,500 feet, or actually a half mile or a mile was about the best it would do for you. And that's what the pilots had to use to find their way around up there to get close to an air base where they could land and refuel. And so we ended up having to use a piece of equipment we brought up there, actually a number of pieces of equipment, to get the kind of precision that we needed to be able to fly line spacings that were 1,500 feet apart. And you can see here Troy and our manager from the Andrews office in Washington, and Ike Harris, one of our senior technicians, flying some of those lines, looking to try to detect the material. This is the navigation system. And we could mount it also on the helicopters, so once we'd find something with a C-130, then the idea was we'd use the helicopter with gear on it, and they would go out and find it. And at the end of the day, then what has to happen is the guys jump out of the helicopter and go out there with a hand instrument and actually get on top of it, uncover it in the snow, and then put it in a container of lead pig that is safe to transport if it was a very hot or intense source. And the sources varied. You can see a variety here. The fuel elements were this little dot over here. These were beryllium control rods, and this was a big reflector that in the drawing shows it down at the very bottom of the reactor to keep neutrons into the reactor. This is, you'll hear more about this from this. Norm Bailey is right here in this picture in one of those recovery operations where they landed and tried to find things. It turned out that the oil lines on the helicopter froze while they were out hunting and it wouldn't restart. And so the Canadian survival specialist on board said to everybody, "You're mine now." And he proceeded to teach them how to put up a tent and build a part of an igloo around the bottom of it to protect them from the winds. And they ended up spending a rather cool night out there. We'll hear more about that in a little bit. Our navigation system worked well, but we had to insulate it, and we built boxes to do that, and we had to go out and refuel them every 24 hours too. Every time you come back in now, you get checked out by the health physics people, and if they find radiation on you, they take that piece of your clothing away. And fortunately, there was a good supply of gloves and boots, so we didn't leave anybody standing out there in the cold. This fella here, by the way, is Joe Tenney from Livermore. And Joe had been out doing these kind of things in the 50s at doing a weapon recovery on a weapon accident. So he knew a lot about operating in cold like this. He was at Thule, Greenland, and then invented one of the key instruments that we used for looking for things. The other thing that you do on any emergency operation is you check your gear. You calibrate it before you go out, and you check it again when you come back. And you have a log sheet that the operator has to fill out as he takes any reading and writes that down. And no matter the weather conditions or whatever, you do that religiously so that you have a hard record that's traceable back to the operator and the individual instrument that took the measurement. At the end of every day then, since the news media couldn't get out there, they had no way to access where we were operating. We would have a press conference in the airport there where we were located. And I'm standing back here in the corner, and my 5-year-old son, or maybe it was Kevin here, noticed for the first time that I was wearing a mustache.
He went around the house going, he's got a mustache.
I think he called him Musher. But we would talk to these guys, and we would put up photographs like I've got around the side of the room here. Rex Wyndham and some others here had a lot to do with taking those photographs, and we'd put the newest ones up of what we found each day. Of course, the Russians kept denying that this had anything to do with them. It wasn't theirs. And when we started putting up these photographs on the evening news that specifically showed components and the radiation measurements, they finally caved in a little bit and said, well, we might have had something to do with that. We'll send you some help. And Colonel Garland said, we're not going to do that. We don't need your help. We're in good shape. And so we pressed on. Our scientists would get together also daily and compare notes on all the parts that they were finding and how they were spread out and what that implied to us about how this thing had come apart. And there are people in there that may be here tonight as well. And of course, our leader here in the middle is Ink Gates, former general, and he was a great leader to have out there. Troy had a lot more hair then, and he was our deputy manager for that operation. And Colonel Garland, who went on to become a general in the Canadian Air Force, so we didn't do him in with what we did for him that day. Good place to quit. What we'd like to do now is take a few minutes break. You can stand up. We'll set some chairs up here, and I'd like to get several of you that can come up and help us out to talk about this thing. I particularly want to get Norm to come up, Norm Bailey, get Rex. I think Thane Hendricks is here. Thane was the guy that helped us with the navigation because we were getting nowhere with that Loran. And then there are a number of others of you that were involved in the operation. If you would like to come join us up here, do that. So 100.
Well, you compromise. One of the interesting things was when the helicopter engine didn't start and we were out there on the river, the Canadian survival expert that was part of the membership got out and we put up 2 tents, one for non-smokers, one for smokers. And then we got out the big knives and carved snow blocks and put a windblock around it. Well, it turned out there was a tent full of non-smokers and only one smoker. Poor guy, he about froze to death. And in the other tent, we had so many that we couldn't all lay down at the same time. So one guy had to be up, standing up or crouch in the corner so the other could lay down. But the tent was warm. There's enough body in there to heat it. So the thing to remember about that is, a full tent is more comfortable than a empty tent in cold weather. And it made a big difference. But I was impressed with the Canadian cold weather expert and his approach to getting everybody to work together, be calm about the fact that the helicopter doesn't work, you're gonna be here for a while, and, but very effective gentleman, and getting us to be a team and enjoy the opportunity to do something different.
What were you really out there doing?
We were out there checking on this report of strange things on the Pannel River. And indeed there were. And you saw some picture where there's some, as we call them, antlers, but they were control tube rods for controlling the reactor. They were sticking out of the ice. And I can remember walking over to another spot, you know, probably 5-8 feet away, and looking down and saying, that doesn't look right. It was a pool about 6 inches in diameter, and it was all melted. No, wait a minute. 30 degrees, minus 30, minus 40 out here, and it's melted. Now what's going on here? And I didn't have enough background to know that some of the insulation that you use to control neutrons, to protect electronics, has an affinity for water. And when it does that, it creates a lot of heat. And so there must have been a chunk of this protective neutron shield that had landed there and melted a hole through the ice. The other one that's kind of, interesting is that's one of the first ones at this site, and I came across a barium cylinder, which is apparently used around the reactor to control its power by absorbing neutrons, or we reflected them back into the reactor. And here I am standing there, here's this piece, and the helicopter is sitting there waiting me to decide what I'm going to do. And I'm standing there and I think, here I am looking down at a piece, but I've got nothing to pick it up with, and I found a shovel in the back of the helicopter, but I got no bucket to put it in. I came out there looking for pieces of the reactor, but I didn't take with me a container to put them in to bring them back. No, so a little forethought does help a lot.
We did have a challenge throughout that operation as we started finding things like that, of not having enough proper lead storage containers. And fortunately, with our connection, we were able to go back to the other national laboratories and have them ship some up to us rather quickly. So we were getting some from Idaho and Hanford and other places like that that were a close airplane flight away to Edmonton to get those things up there. And we were having to do that kind of supply throughout the operation. Going to ask Alan here about, you just heard a little bit about how the people were surviving this operation. How the equipment, how did the equipment stand up in that kind of cold?
One thing I don't remember was, I think we had Radar 3 on the helicopters when I was at Cosmos Lake, but they weren't designed for 35 below zero, and those detector crystals break when they get cold. So that's the part of my memory from 40 years ago that I don't remember very well. But I remember a lot of other really interesting things I'll tell you about. Starting off, I used to work for Lawrence Livermore Lab. In 1973, I designed the world's first portable gamma ray spectrometer, which I see is right over there. If somebody takes the cover off of it. Yep. It was designed for the NEST mission to be covert. That's why it's built in Samsonite luggage, so you can't tell you're using it. And there's little push buttons on the top. You can walk over and press a button and walk away. and then come back and get it later, and it'll tell you what isotopes of what radioactive materials are nearby. And so we actually took one of those, or maybe they had a couple of them up there at Morning Light. I think Livermore brought them along, and I don't see any pictures over there of anybody using them. But anyway, that was in Edmonton. And I started out a little late because I was sick, and so I didn't go up in those 2 planes you saw in the beginning. I went up much later. And by the time I got there, there was still plenty of time to do missions on the C-130s. So I flew 100 hours on C-130s, very boring airplanes, very noisy. But we'd go up and the flight deck, the cockpit with the pilots, and they'd be sitting there with their feet up on the console, flying the plane with the autopilot knob, making turns, flying 100 feet off the ground. Those are wonderful, wonderful airplanes. This is the one you see in all the war movies of the Special Forces guys using. Anyway, so after that, those 2 Canadian explorers that you saw in the picture that found those antler things like 300 miles east of Edmonton, the Canadians said, we're going to set up a camp there on the ice. And they flew in airplanes and landed on the ice and took out earth-moving machines and snow blowers and trucks and helicopters. And they built a camp there with 100 soldiers, maybe 10 or 20 of these huge military tents. And they said to us, we need a volunteer to go up there and run all the gear and search for radioactive stuff up there. And no one said anything except me. I said, this is high adventure, I'll go. Everyone else wanted to stay in Edmonton at the Holiday Inn. So I went up there, and first we had to go to cold weather training school where we were taught how to wear that clothing that you see in those pictures. And it is wonderful, wonderful clothing. It's not down, it's wool. And the boots, you're sitting inside of those mucklucks, you're standing on a half-inch thick piece of felt. And what they tell you is, at night, you take your boots off. You never want to wear all your sweaty clothes when you get into your sleeping bag. You take off the boots, you take out that felt pad, and you lay it next to your sleeping bag to where it'll freeze. In the morning, you grab the felt pad and you bang it on something real hard to break all the ice off of it, and then you put it back in your boot. Otherwise, it would melt when your hot foot gets on top of it. And they said, and the first thing you got to know is you never want to over-exercise. Don't ever get sweaty or you'll freeze to death. And I unfortunately didn't follow that once. We were at a fuel refueling place. These were Huey helicopters that we were flying. And I don't know how the fuel got out there. It must have taken them a long time to keep taking one helicopter out of one can of gas at a time and leaving it there. But while we were watching them refuel, you know, it's 35 below zero, and so I'm walking around like this, and I walked around a little too fast, and my feet got really, really cold. Another time, we landed on top of an esker. Because you're not a Canadian, you probably have never heard of an esker, but it's a long row of gravel about 100 feet high and 1,000 feet long, and there's hundreds and hundreds of them up there left from the glaciers. And we landed on top of one of these things, and I don't know, they weren't refueling because that's not a good place to refuel. I don't know why they landed there particularly, but a guy was standing this far ahead of me looking at me, and I watched his nose get white while he was standing there. And I said, nose, 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 and he put his glove over his nose. He was getting frostbite. But anyway, so I went and, I hate to say I ran the camp, but I did a pretty good job of planning the missions of where the helicopter was to go. I don't remember using more than one helicopter, maybe Thane knows. I think we only had one Radar 3 or whatever. I don't remember that part at all. But I remember I would make a plan of where we want to go during the day, and we'd get in the helicopter and go out there. And when the equipment on board would find something, we'd drop a little red flag, and then we'd go land on the ground and take a little handheld meter and go over and find it, and then take turns trying to dig the stuff out of the ice. And it's usually about a foot deep because, you know, it just melts enough to get past the top part. I found one of the items I think Jack showed a picture of. It was the biggest, most radioactive piece I think anybody ever found. It was a solid beryllium cylinder, 3 inches diameter and about 10 inches long. And we measured it to be 6 Rontgens per hour at contact. That's not millirontgens per hour, that's Rontgens. That's like deadly. And I dug it out of the snow with a shovel. And the lady back there was saying, well, you know, what'd you use for protective gear? And I said, there is no protective gear. And eventually they put it into a pig, and then another airplane would come in and take the pig away someplace. But Zolan Burson was out there. He was another EG&G person. I wasn't working for Livermore at this time. I was working for EG&G. Zolan Burson was one of our people, and he went with us one day, and he got his foot contaminated. And we had to put him in a plastic bag to put him back in the helicopter, or else the radioactive particles on his boot would get in the helicopter and contaminate the helicopter, which is what you're using to measure the radiation. So that's like terrible. So anyhow, so that was really a lot of fun out there. But the most exciting thing was at the end, I was out there running the place for a week. The last night I was there, the last night anyone was there, the cook tent caught fire and burned the camp to the ground. And I have pictures of all this stuff that I gave to the museum, but they're not any of those pictures, and I hope they're over in the museum someplace. But there was burning magnesium and propane from all these heaters, because they had to have these propane heaters, which were very lightweight, with these big plastic ducts to the helicopters to keep them warm all night long, or they could never start. And all the trucks that they had there were left running 24 hours a day, or they couldn't start. So they had all this stuff happening, and it was really exciting. I had some pretty good pictures of that. And they finally blew it out with a snowblower.
Yeah.
And then we all left.
Yeah, we could be here all night just hearing each one of our individual stories about these things. Let me ask Thane about the issue of where the heck we were. You know, you start with Loran C, which isn't doing you much good.
Okay.
And so we ended up having to use our own system that we brought with us.
I can address that quickly.
Do that.
One of the first committees that was formed up there was what they called the HIT committee. I was part of it, and we had a number of people who were radiation physicists and various disciplines. We'd done one flight with one C-130 right down the center of the path, we thought. We found nothing, not surprising. We flew another flight with 3 aircraft flying in formation, one with a little bit better positioning information in the center and the other 2 on the wings. We found nothing. So we were having a discussion about this. The Loran, Jack gave it a lot more credit than
It deserved.
It's not good to a quarter of a mile, closer to 4 miles. And we happened to be in this HIT committee in the front part of one of the offices, and we were arguing loudly. I'd been involved with the positioning systems, and I knew what the Loran would and would not do. So I was a little bit vociferous about saying it's no good. It won't get us within 4 miles. And everyone was there, not to the experience, said, well, they've got the best positioning in the world. They can find people out in the snow and all of that. I said, they haven't got it suitable for here. About that time, a fellow walked from the back office that was attached to this office. And he said, I don't know who was talking, but he says, I'm the head navigator. And on a good day, you might get 4 miles. So everybody looked a little bit shocked. And since I was making the most noise, I was elected to go
Solve this problem.
join the committee. I thought it was a death notice. I was to join the committee with Norm and the other people from the lab. And in essence, since I was tired, we've been fighting it, we didn't know where we were flying. And if we'd have found something, we wouldn't have known how to get back to it. So I said something to the effect, stop, we're wasting our time. And the looks on the people's faces was something, I wish I had a picture of it. Jack, I think, was wondering, oh my, what has Thane said now?
I could tell what was coming.
But then we discussed the situation that the 2 flights that we had done were useful. If we'd have found it all in one piece, that would have been great, but we were wasting our time. And so Garland agreed, which I was happy about, so I thought I had an early ticket home. And we put together a system that we had been working that was pre-GPS, It was using transponders, and at that time, it was good to within 2 or 3 meters. It required putting it down on the ground, and we had developed a steering indicator. Al Valer, who is hiding back there somewhere, Al Valer had put together a package using software that we had developed for doing environmental surveys. And so he was very busily engaged working with Quentin Bristow from the Canadian group that had developed the acquisition system. Long story short, we put together a system. We then went to work, and all of those nice pictures you see with the almost parallel line came from this steering indicator that Al Valer put together.
Yeah, we had two.
You don't have to say anything now, Al.
We had 2 big vans that we brought with us on the 141 that were parked in the hangar there at Edmonton. And in those vans, we could process the data from the helicopters. And so they ran continuously. I don't think they shut down the whole time we were there, or that we were flying. And so we had people working around the clock on those things. The other thing that I remember about the whole operation, for that first 2 weeks that we were up there, Troy, we figured that we were working 20-hour days. And of course, being the crew from the test site that we were, you didn't waste the other 4 hours sleeping the entire time. You had to go have a snort somewhere. And at the officers' club, it turned out that one of the clever bartenders there invented a drink called a morning light, where he had a blue cacao liqueur that he added a few other ingredients to, and made a cocktail that had the name Morning Light on it. So we had to go try those out, but you'd relax for a little bit, and then you could sleep, and then you were back up and at it, and it was that way for 2 weeks. And the point was that it would be the same anywhere, particularly in a heavily populated area, if you found yourself confronted with that serious of a radiation hazard potential, until you could really get a handle on the thing.
I have one other quick item that we think about the fact we went up there and had all the answers. We didn't have all the answers.
We invented them
That
while
was-
we were there.
That was in the day that everybody was using PDP-8s. That was the machine of choice. That wasn't what we used. We used a Data General, a newcomer to the world, for our processing system. Not expecting to see another Data General anywhere. Quentin Bristow, who was the analysis guy for the Canadian, had based his system on what? Data General. He had chosen, as we did, a Tektronix monitor scope, which was not standard with that computer, but we both chose it. We both chose incremental plotters. Both had the same 9-track magnetic tape. So we had, in our system, we had several primitive commands, since we were still developing a lot of the things that we were doing. Primitive is, I mean, without knowing formats, you could read a tape and do a dump and see what it looked like in a printout. Well, as it turns out, within a few minutes of getting a tape from the Canadians, hoping that we could do something with it, we were able to read it and see where their spectral data was, and started immediately processing data for the Canadians. The first hit that we got was taken with Canadian system, the first honest goodness hit, Canadian system, but processed by the U.S.
Yeah, we just can't say enough about our ability to work with each other up there, and thank God we both spoke English. You have to deal with the A's on the end of everything, but other than that, we got along really well. Now, one other person I want to not leave out here, because you see all these photographs around here, and taking photography in that kind of weather, that kind of climate, is a challenge for everybody. But our photo team, first thing, they unloaded the gear out of the airplane and we went to the base photo lab, and it was beyond primitive. And by the time we moved all of our stuff up in there, we had probably improved the quality of their photo lab by a factor of 20 or more, wouldn't you say, Rex? And so then they proceeded to gather photographs. And as I mentioned when we started, that was the only way that the news media could follow what we were doing. So every night when we did our briefing, we'd put up photographs that size, and the media would come over there. Of course, now the media, being as inventive as they are, they'd take one of these photographs and they would walk with their camera around and make it look like it was a live piece of footage, and they'd be telling all the stories. So, Rex, you got involved with them on that.
Oh, well, I think, Jack, this is where our memories get a little cloudy, right? I was probably the youngest one up there, and just a year or two past being 21, and it was the greatest year of my life. We did a lot of interesting things, not just morning light during that time. Working with these gentlemen where I had a lot of respect for them. They were very intelligent, and I trusted them. And even when we landed in Edmonton, and my boss said, "Oh, don't worry about your suitcase. We'll take it and to the hotel, and you go on up 600 or 800 miles up the road and see what's going on." Well, the pair of Levi's that I wore, I stayed in for 11 days. And it was a fantastic experience for me because I didn't know how large the world was. And to go out amongst areas that were so expansive and so beautiful, it was really quite the eye-opener, and I got an appreciation for irony and a lot of different things like that because I thought the world was really large after that. Well, the next year, a friend of mine, another photographer, we said, "What should we do for the 1-year anniversary of Moonlight?" I said, "You know, we'll take snowshoes and we'll snowshoe up Mount Charleston." Well, not a very good idea. I can tell you that for sure. We got about halfway and said, but as we're stalled out, kind of worn down, we looked up and there was this gentleman cross-country skiing, and who was it? It was one of the two guys that found the morning light piece. He was, I mean, a small world. He'd decided he'd come to Las Vegas. He said, "What should we do?" We should go cross-country skiing. I said, "Okay." So there really only is 200 people in the world. But a great experience. I really think Paul Mudra said it right when he said, "You know, you'll remember this experience for your life." You know, and he really did.
Yep. You were in the airplane that didn't start. So
Oh, yeah. Oh,
that,
yeah.
that photograph is one of your pieces of work. I think you also had some photographs of herds of animals that were kind of
Oh, yeah, the muskox and different things like
caribou,
that.
I think.
And ancillary note, I learned that there was 168 hours in a week. Because when I got back, they determined that I was always on pay status. So they gave me a check for 168 hours. And I bought a 1978 pickup truck.
Yeah, a lot of our folks did make out very well there. They,
A lot of them weren't quite as lucky.
No,
Or did not get.
us
the
managers
detail.
ended up on the short end of that stick.
They had to give most of it back.
They did give us a few extra hours, but for the most part, but the troops did pretty well on that. What were the challenges about the extreme cold, Rex? Did that really affect the film very much, or?
Well, the biggest challenge was the really fancy cameras that we had. They hadn't been prepared for winter operation, and the grease between the shutter of the lenses froze. So the cameras that worked were the inexpensive little recycled Japanese beer cans that we kept underneath our arm, you know, to keep them warm. Those cameras worked, and the fancy cameras, they would work if you kept them warm. That was it, and it was not warm.
It turned out on a lot of those other hand instruments that you see them in these pictures out there operating, that the battery packs in those things would freeze on us. We ended up having to remote most of those to batteries that you had inside your parka and have the wires out there. Now, as long as the thing could sit in the cold for a while and adapt, it would work okay, as long as you kept the battery pack protected. Do you have to do any of that, Alan, or you just, I guess some of the other
pictures with-
technicians got involved with that?
I had a crummy camera and I kept it in my parka and it worked fine.
Yeah, yeah. But you can hear from Rex that if you take one of the good ones out, it might freeze up on you. And, I mean, you run into one issue after another that keeps surprising you. What I'd like to do right now, though, is kind of stop our discussion for a few minutes and let anybody in the audience that wants to ask us about things, maybe Troy wants to come up and quote some more of Service's poetry to us.
Thank you, good. Go ahead.
Any questions that those of you in the audience would like to ask any of us?
For us not so initiated, could you please describe what a pig is? And how it's named?
It's a technical term that the health physics community used to describe a container that provides radiation protection that's the right amount of radiation protection for the size source that you're going to put in it. Some of these sources, like they described here earlier, were hot enough that they required a very heavy pig that when you get out there in that snow, you had to have it on a sled so that you could even move it. And then it went on a separate airplane from the one that your crew was flying on. And they would fly those things first back to Yellowknife. And there's other pictures that you'll see where they characterize each source and make sure that it is packaged correctly in case they need a bigger container or something like that. And then eventually all those fragments got taken to Whiteshell, which is the Canadian equivalent of one of our national laboratories where they do all their research for their reactors and that sort of thing. And so those fragments ultimately all were brought there and assembled there. But the pathway was kind of circuitous, but it generally led through Yellowknife and then down to Whiteshell.
Jack,
Yes,
important point, pigs are made of lead.
yes,
It's not trivial.
yeah, and that's what makes it so heavy is lead is the preferred material for that kind of shielding. And so it may have an outer container of some kind that makes it easier to haul and move around, but the material inside has to be lead in order to provide an adequate amount of shielding for a small volume container. Did that answer your question? Or any other terms like that we've been using?
You mentioned briefly you didn't have protective equipment. How did you keep from getting irradiated picking this stuff up out of the snow?
In
Well-
the square law.
Yeah, there's several ways that you do that, and of course, the main one is keep your time of exposure as short as you possibly can. So once you have an idea that you're dealing with one of these high R sources, you manage your work so that any individual is only there for a short amount of time, and then you pass the duties off to the guy behind you to finish the job if it's that serious of a thing. What there are, keep in mind, we're in 78 now, and the rules have changed so dramatically in that world that you probably couldn't even do an operation like this today because the restrictions would prevent you from going in there and doing some of the things that we did.
Picking up an irradiated piece of metal with a snow shovel, probably.
Right.
That by itself wouldn't necessarily be a problem. I mean, we've recovered things like that before. We had a lost source out in the middle of Kansas that we recovered, but we had a number 3 wash tub, and we filled it with sand, and then we had a gallon paint bucket in the middle that was full of water, and that became our pig. And we picked the source up with a shovel and dumped it in there. And just, did it very quickly, but it was a source that required you to take precautions. And that's why it was very important to have health physics trained people with us, But one of the major differences we learned, and this came home in spades a year later when we were at 3 Mile Island, is that the state of Pennsylvania had 8 health physics people in their office there in the Capitol. And the kind of experience they had was going out to doctors' offices and checking on x-ray machines and stuff like that, and on the few industrial sources that were running around their area. And they really had nothing that was equivalent to the kind of field experience that the people that we could pull together, not only from the test site, but from Livermore, Los Alamos, Sandia, and the other major sites around the country that are involved in field work. Oak Ridge, Savannah River, Idaho, Hanford. And so it turned out that having the ability within government to call that group in as a team, which is what we were doing, we could respond to a serious incident that might involve radiation. Now, in the case of 3 Mile Island, we didn't have anything significant outside the containment vessel. But there have been other situations we've been in where you might have had pieces scattered around. Nothing that was equivalent to this thing, however. We volunteered to go help with Chernobyl. Thank goodness the Russians didn't want our help. That is not a place you ever want to go. Yes?
So what percentage of the material do you think you recovered in the end?
1%. Again, what I tried to point out early on was our job was not to try to go out there and recover all the pieces. It was really to identify, first of all, we thought we knew what the source was, that it was this Ramashka designed reactor because they had published in the literature descriptions of this reactor. Now, it turned out they were constantly changing and improving that design, and so we weren't exactly sure what it might look like. So one of our first jobs was to try to confirm that the reactor we were dealing with was that reactor. And I think we found enough pieces to satisfy ourselves that that was true. Then the next thing you want to know is, how did this thing come apart as it was reentering? The radioactive sources that the U.S. has built and launched are built so that they will totally withstand reentry, and they would all be in one piece. In this particular design, however, that was never intended to be returned. It was supposed to be boosted up into a 500-year orbit. And by the way, they have 20 of these up there in that kind of an orbit. So in 500 years, somebody's going to have to worry about them, but not us, fortunately. And of course, you go to each of the villages where you had larger numbers of people, and you would survey those very carefully to make sure that they weren't being exposed to something that somebody had picked up and brought into the village. We were really worried about those natives down there on the south end of the Great Slave Lake, that maybe a kid would step on one of those little fuel fragments, have it stick to his mukluk, come into the house, thing falls off his mukluk, and then you've got the baby crawling around on top of it. You know, that was the kind of scenario we envisioned and were looking at, and so we and the Canadians both were really trying to protect against something like that happening. Any other questions out there? Well, I know that this is a topic that we could go on with forever, but we'll try not to do that. And you've seen all of us up here, and there are a number of others. Let me get a show of hands in the room of people that were actually up there during this operation. So you can see we've got Troy here was our commander for that operation, and the commander of a number since then. And so we thank.
What was the total length of time you were out there?
Our team as a whole was there for 3 months. And in fact, that's one of the other problems when you get deployed on one of these things is the National Security Council deployed us, and what comes along this is, oh, by the way, nobody leaves the room until the president approves it. So you get up there and now you're stuck with it until the president says it's all right for you to come back. And same thing happened to us at 3 Mile Island. And so at the end of that 3-month period, we had a sufficient description of the source, how it was spread out, what the hazards were. We felt like we had found some of the larger hazards that existed and had removed those from populated areas or anywhere close to population. And we felt it was safe to quit. But we had to have the Canadians buy off on that. And when they, through their State Department, communicated to ours that they were satisfied, then we got a release and said, okay, you pull out. Now, we still had people that stayed behind. We had some health physics that took a sabbatical, or they quit RICO or whoever and went to work for Canada and stayed up there. And the possibility always exists that they may want to keep some of your equipment. Now, that didn't come up in this case because the Canadians had a lot of their own equipment. That was fortunate. And the fact that we were able to make our processing software work, because their equipment was really designed for prospecting for uranium deposits and natural isotopes, not looking at a hazard like this with a reactor. And so the software we were able to provide them with gave them that kind of a capability. Yeah.
Jack, what happened the following summer in terms of searching for crap that was left over?
I personally don't know the answer to that. I know that we had people still up there and they were still doing that. All the fragments of that reactor core that were sitting on the Great Slave Lake, of course, when it melted, go to the bottom and end up in the mud down there. But it turned out by July, you could not detect one of those individual fragments any longer. So the short half-life isotopes that were there had decayed rapidly, and we just, you couldn't see it. So I think there was not a whole lot of concern or worry about that. But you know, if you were down in a climate like ours here, it'd be a whole different story. Good questions. Any other comments or questions from anybody?
I'd just like to make a comment in that it's just how great it was to work with everybody, and everybody to work with you. You know, it was, I guess everybody have a sense we're in this together. Let's do the best we can and help each other out as much as we can. And the comradeship was just unbelievably great between the people bringing us stuff or taking stuff out or with each other. And I even worried about details like, you know, we heard about a tent burning down. With the sleep tent we had out there at the site, they issued us a knife in case the Bunsen burner that was heating the tent caught the tent on fire. You make your own door to get out. It was that sense of being concerned for the other guy and helping each other out. It was just great, unbelievable.
Of course, you did have an incident there one night where I think it was one of the Livermore guys that had a big bushy beard,
Yeah.
got his beard frozen in the zipper on his bag and couldn't get out of it in the morning. That required a little special effort to sort that one out. But you know, you just learn about hazards you never even thought about. Well, this was, as you can tell, it was an exciting time, and all of us still have those memories, as old and decrepit as we've become. And we still enjoy talking about it and remembering about it. One other group in the room that I haven't given credit to is our wives had 3 months of running the store. And I know Julie organized a lot of the wives here in town that were like we were, had people that were up there for like 3 months. And they often had to help each other out with the damn water heater broke, or the refrigerator quit, or pipes leaking, or whatever. And so as a team on the home front, they were helping us keep things under control.